At Recupel, we collect enormous amounts of waste electric and electronic equipment every year. Taking samples allows us to understand the distribution of this waste stream. This is required for various financial and reporting purposes. Before the start of the project, the sampling process was rather low-tech. A small webcam was used to take one picture of the appliance, and the corresponding category was selected manually by an operator.
So we initially got involved via Recupel. They wanted us to have a look at their sampling setup. They had about 1.2 million pictures of webcam pictures of small domestic appliances, and they wanted to check whether artificial intelligence could be helpful in detecting what type of product it exactly was. What we did for them was the following. We built a new machine learning model that is able to detect automatically what type of electronic waste we have for their sampling. So we use 6 high-quality cameras for that together with a scale, and we use artificial intelligence to detect automatically what type of product we're talking about. The way it works is as follows. The operator has a box of appliances, and we will put each appliance on our sampling installation. Each sampling installation has 6 high-quality cameras. We take a picture simultaneously of the product and then feed it to our AI system in the cloud. Our AI system in the cloud will then detect or predict what is actually on those 6 pictures. It will select the top 3 likely candidates. The next step in this process is the labeling. So after we predicted our top 3 likely candidates, we send it to our labeling tool. There, the operator will offline select which one of those 3 was actually the correct one to make sure that the results are perfect. We use the same type of data to also train the AI model to improve its performance over time. The current system works quite well. We're able to support 116 product types. This is 85% of the entire Recupel sampling process. And we're able to have a 96% accuracy in that top 3 prediction. Next to the existing sampling setup, we also explored the idea of further automating the process of electronic waste detection and sorting. For this, we deployed an initial prototype of a conveyor belt, where on that conveyor belt you put electronic waste. It goes through a tunnel with 3 high-quality cameras and a scale. And similar to the existing sampling setup now, we also detect using artificial intelligence what product it is. The advantage of the conveyor belt is that you can fully automate the entire sorting process with this. This is, however, a first prototype into the full automation of electronic waste sorting. The conveyor belt setup has 3 main advantages. First, it's much more mobile. This means that we're able to replicate that conveyor belt to different locations. Second, it has a higher throughput. It also means that we can put more products on the conveyor belt per minute or per hour. And third, it achieves much more potential towards full automation. We're able to split specific products using the detection of the AI onto a different conveyor belt so that we can sort more efficiently. While we physically have 2 different setups, a sampling setup and a conveyor belt prototype, under the hood they're using the same AI technology. It also allowed us to very efficiently transfer the knowledge we gained through the sampling setup to the conveyor belt. In only 3 months, we were able to get the same accuracy numbers from the sampling setup towards the conveyor belt setup.
Thanks to the new installations, we collect more detailed and more accurate data. We also made a jump from category level to product level recognition. This allows us to do more specific detailed analysis, and we can combine and regroup the data as we desire. The conveyor belt test results look very promising, and we are currently looking into the future applications of this technology.